Hello everybody, I'm Alan Jackson. I'm the sales manager and applications engineer for CyberOptics based in Minnesota. And thank you for the opportunity to be a finalist in the Best of West award here at Semicon West. We're very honored. And what we do at CyberOptics is make wireless wafer-like metrology wafers that do leveling, vibration, particle sensing. And what we have come out with this year is a multi-wafer that does leveling, vibration, and has 5 humidity sensors. Primarily, what the humidity sensors are and what has met a really critical need in the advanced 29 nanometer fabs and below is the ability, what's happening in these 29 nanometer fabs and below is that the IC process, they're sensitive to moisture in the process, and as the technology nodes advance, it becomes more critical to control the humidity. And then these new relative humidity control requirements create a need to more easily characterize and measure humidity so as to prevent yield loss. The adverse effects of relative humidity in certain critical processes in the wafer and reticle environment are lost yield. And in wafers, there's also a phenomenon called TDH, the formation of time-dependent haze. And in the reticle environments, when moisture is present and not controlled properly, there is a phenomenon called reticle haze that forms on the reticle and can shorten the reticle life. Up until this point, and before our auto multi-sensor was released, some of the more crude methods and ineffective methods of monitoring and controlling humidity included FOUPs with wires, wired humidity sensors going in, and controllers, very cumbersome, unflexible, handhelds, which you compromise the production environment by opening up to do a wand or a handheld humidity sensor. And also there was a design where humidity recorders are taped onto a wafer and put into a FOUP to measure humidity and record it. Of course, this is very cumbersome and time consuming because you have to take the wafer out, download it to USB, synchronize everything up. So all of these are very ineffective ways of monitoring and controlling humidity in the wafer environment. Another way that's quite common is just measuring the humidity at the outlet port with a single manometer far removed from the actual wafer environment. There's a number of drawbacks to this, one of which is it's not reflective of what the wafer is actually experiencing in regards to humidity, either top to bottom of the FOUP, of the PURGE FOUP, or across the wafer surface. There's always a delay at the exit port. It's just a very ineffective way, an unrepresentative way of characterizing humidity in the N2 PURGE FOUP environments. So we, this year, developed due to customer demand, and it's been very successful to date, our AMS wafer, which in addition to 5 humidity sensor in the 300 millimeter version, includes also a vibration X, Y, and Z, and also leveling to have a full-featured all-in-one wafer. And also we have, in addition to the AMS 300, we have the AMS RQ, which is in reticle format. The only difference being it's of course in reticle, it has a 1 humidity sensor. And it's compatible with Nikon, Canon, and ASML scanners, so it can be introduced straight into the scanner or the reticle mask environment. So the advantages of our AMS 300 in the PURGE FOUP environment or the reticle clean dry air environment is it's real time and actually records data and downloads it using Bluetooth to the application on a laptop. It's very easy to use. It's real time, and you can qualify the relative humidity environment in the N2 PURGE environments under actual conditions. Our AMS wafer moves throughout the environment just like a wafer. That's the whole concept behind our WaferSense line. Or just like a reticle, that's our concept with the Reticle Sense line. It moves to all locations. In the case of the scanner, it goes to the reticle library, the reticle stage, reticle stalkers, wafer stalkers that could be N2 PURGE FOUP. Basically, it goes wherever the wafer or reticle goes to characterize actual humidity conditions and to get a true characterization. You see here, a typical PURGE FOUP might have 3 inlet ports and 1 outlet port and diffusers in the back. And so as the N2 purges, with AMS you can characterize throughout the entire PURGE FOUP environment what's actually going on. So here's a case study of a typical scenario in an N2 PURGE environment. We're at atmosphere, and then has a maintenance purge where it's purged down to 5% relative humidity or less. And open the door up. And then here with a process purge where the target is 20% relative humidity. We see here that of the 5 sensors, only 4 of them are going to the desired 20% purge. One of the sensors is detecting that it's not getting to the target 20%. It's actually 32%, and it's actually a lot higher. And this non-uniformity in this environment could cause various defects or yield loss. It can be indicative of the purge diffusers not working properly or something that needs to be fixed in this N2 environment. And so with our AMS multi-wafer, we can easily characterize that. Where before there wasn't really adequate, easy tools to characterize the N2 PURGE environment. So we see here it just never went down. Coincidentally, this laggard here that did get to the target purge humidity percentage was near the outlet port. So it just that would be something that would be needed to be addressed. And in our AMSRQ, which is our reticle version, it travels in the stalkers, SMIF pods, throughout the reticle stage, basically every place the reticle goes, because any place that the reticle travels to or is stored is an opportunity for water to attach itself to the reticle. And when that happens, that could help perpetuate reticle haze and shorten the life of the reticle. And reticles are very expensive. So with a product like AMSRQ, users are able to find out where humidity and moisture is introducing itself, and corrective action can be taken. Here's just an example of a reticle haze as it forms, in part caused by humidity in the reticle environment. Being a multi-purpose reticle, multi-purpose wafer, there's also the vibration function that's included. It does X, Y, and Z vibration in addition to the 5 humidity sensors on the wafer or the 1 humidity sensor on the reticle. And this vibration characterization is important for proper handling. And also it's used in conjunction with the PURGE function. If the PURGE is too fast, there will be vibrations that could cause wafer damage. If it's purging too many liters per minute, the AMS will show that. And here's a case study of tuning a robot for smooth wafer handling and reduced vibration. In addition to scratching, vibration can cause particles, and our AMS wafer is good for assuring proper handling. And also, what's important, also included in our multi-sensor, is a leveling function. It does X and Y leveling accurate to 0.03 degrees for proper inclination of the reticle at the reticle stage and throughout the reticle environment and in the wafer. Make sure that the pins are level, make sure that the pickups and handoffs are properly calibrated. So it basically is a very useful product that we've developed that's been quite successful and has met a need in particular with the advanced fabs that have introduced into PURGE environments. Well, thank you.